Let's explore further this idea about velocity and acceleration and the directions. Now imagine a car, right? That's a car, a nice car, and this car is going along in this direction. All right. Now suppose that at first it has a speed of 10 meters per second. Now this car travels for some distance. Okay, let's say maybe 40 meters, and then it arrives here. So the car arrives here. Okay, draw that again, and the car there, and the wheels there. Okay, after 40 meters. Now, after 40 meters, when it arrives here, let's say that it has slowed down to a stop. 0 meters per second. Okay. Now, and suppose that the time taken is okay, it's 2 seconds. It's taken 2 seconds to slow down to a stop. Right. Okay, let me get the numbers right. Now, okay, so let me change some numbers here. Calculation. Right, let me change that to 5 meters. So I'm going to call that 5 meters instead. Give my pen back. So suppose that this distance it has traveled is 5 meters. Okay, so the car has slowed down to a stop, and then it goes backwards. Okay, now I'm just going to, alright, to avoid confusion, I'm going to draw this separately. Alright, from there the car moves backwards to maybe here. Okay, so from there the car moves backwards to there. Now it's moving in that direction. Okay, with say a speed of 3 meters per second. Right. Now, and right, I'll change that as well. Let's say that's 1 second. Say that's 1 second, and let's say the car takes it turns back here and moves by a distance of say 2 meters. So we have this situation. What I'm going to do is I'm going to try to calculate a few things about the displacement, velocity and acceleration. Looking at the, say, the acceleration for a start. Now suppose that I want to find the acceleration when the car moves from there to there, moves from here to here. So how should I do that? Now we have the formula, we know the formula for acceleration. Now acceleration, I'm going to write it in a shorthand notation. I'm going to use A to represent acceleration, and I'm going to use V and U to represent the initial and final velocity. Okay, and I'm going to use a minus sign to represent the change, and T to represent the time. So now that means that I'm going to take U. I'm going to take U to be the starting velocity, so that's going to be my U. I'm going to take V. Alright, I'm going to take V to be my final velocity in this case. And since velocity has direction, I need to choose a direction to be positive. So I'm going to choose the right side to be my positive direction, so the left side there would be my negative direction. Okay, so in which case the starting velocity of 10 meters per second would be a positive number because the velocity goes to the right. 0 is neither positive nor negative, so I can just leave that. And the time t is 1 second. Okay, so I have here the final velocity. Write this down. That's the final velocity, final, and that's my initial velocity, initial. Okay, and that's the time there. So with all the information that I already have, I can put in the final velocity, which is 0, the initial velocity, which is plus 10, or just 10, and I divide it by the time, which is 1 second. So if I do this calculation, I have minus 10 over 1, which is minus 10, and the units are m and s to the power of minus 2. So I have an answer here. The answer is minus 10 meters per second. What does it mean, a minus acceleration? Now a minus acceleration can actually mean two things. Now in this case we've seen that seen this velocity going to the right and slowing down. So it's actually a deceleration. Okay, so a negative acceleration would actually mean a deceleration, so which is what we have here. A deceleration. That means that the car is slowing down. Now, but a negative acceleration has another meaning. It can mean that the minus sign would mean to the left, so it can also mean accelerating to the left. So in this case, the minus sign here can either mean slowing down to the right or accelerating to the left. Now let's see this, have a look at this second possibility. When I have this car here. So for this example, the car is at first at this position here, where it's 0 meters per second. Alright, when it turns back and moves to the left. Now I'm going to keep my convention of positive on the right, to the right, and negative to the left. So for this second part of the motion where the car starts moving to the left, if I try to calculate my acceleration again, I have acceleration is equal to okay, using the same symbols, the final minus the initial velocity divided by the time. And in this case, my initial velocity is 0, just 0, and my final velocity is 3 meters per second. Now, because this time it is moving to the left, I need to put a minus sign to indicate that. And now I'm ready to put these numbers into here. Oh, I need a time as well. Well, suppose that this time the time taken for this motion is 0.5 seconds. Okay, so then if I now plug all these numbers into the equation, final velocity is minus 3 meters per second. Oops. Okay, I put down minus 3, minus the initial velocity is 0, and the time taken is 0.5. So therefore the answer is just minus 3 over 0.5, which is minus 6 meters per second squared. So now we have a situation where the acceleration is also minus, and we have the car moving, the car here moving to the left and going faster and faster to the left. So in this case, the minus sign here means accelerating to the left.